Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So to solve this, I'm going to first start by rewriting 15 as 3 times 5. So now I have 3 to the power of x times 5x squared, 5 to the power of x squared is equal to 3 times 5. Now, I'm going to divide both sides by 3 to the power of x, as well as 5. So then, for my left-hand side, both the 3 to the power of x's cancel out. For my right-hand side, both the 5's cancel out. So now I get 5 to the power of x squared over 5 is equal to 3 over 3 to the power of x. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 5 to the power of x squared over 5, that's the same thing as 5 to the power of x squared times 5 to the power of negative 1. And now this is equal to 3 times 3 to the power of negative x. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So, in this case, I get 5 to the power of x squared minus 1. And now this is equal to 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can move this exponent and b to the front, so it's going to equal b times log a. So in this case, I get x squared minus 1 times log 5 is equal to 1 minus x times log 3. And now, I'm going to take base 5 on both sides of both logs, so these cancel out to get 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And this means that x squared minus 1 plus x minus 1 times log base 5 of 3 is equal to 0. And this gets me to x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0, meaning this is one equation, x minus 1 equals 0, meaning x is equal to 1, and if you solve this, you get x is equal to negative log base 5 of 15. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 80. So to solve this, I'm going to first start by subtracting 80 on both sides. So I get a to the power of 3 plus a squared minus 80 is equal to 0. Now I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. So I simply wrote negative 80 as negative 64 minus 16. And now, negative 64, I'm going to rewrite that as negative 4 to the power of 3. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16, I'm going to rewrite as 4 squared. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if by using these two properties, I'm going to end up with a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. And this simplifies to a minus 4 times a squared plus 5a plus 20 is equal to 0. So now this gives me two equations. I get a minus 4 is equal to 0, and a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, a is obviously equal to 4. And for a squared plus 5a plus 20 equals 0, I'm going to use the quadratic formula, but I'm actually not going to waste your guys' time by actually doing it. So if you do end up doing it, you get that a is equal to negative 5 plus or minus the square root of 55i over 2. And the reason, actually what you should get is a equals negative 5 plus or minus the square root of negative 55 over 2. And the square root of negative 55, I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace I with the square root of negative 1, I get a is equal to negative 5 plus or minus the square root of 55 I over 2. So that's how I got square root of 55i. Alright, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1 over 3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this video, I'm going to be solving the problem 9 to the power of 900 minus 9 to the power of 901. So, to solve this, I'm going to first start by evaluating my terms. So we have 9 to the power of 900 and 9 to the power of 901. And these two terms are pretty similar, except that the exponent for 9 to the power of 900 is 1 less than the exponent for 9 to the power of 901. So the easiest way to solve this is to simplify this as much as we can. And a way to do that is to factor out a term. Well, 9 to the power of 900 is actually a factor of 9 to the power of 901. So all we have to do is rewrite 9 to the power of 901 as something times 9 to the power of 900. Well, we can use properties of exponents to do this. So I'm actually going to rewrite 9 to the power of 901 as 9 to the power of 900 plus 1. And now I can use the exponential property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 9 to the power of 900 minus 9 to the power of 900 times 9 to the power of 1. So now from here, these two terms have the number 9 to the power of 900 in them. So I'm going to factor out 9 to the power of 900, which is what I said I was going to do at the beginning of the video. So now I get 9 to the power of 900 times 1 minus 9 to the power of 1. And this is equal to 9 to the power of 900 times 1 minus 9, because 9 to the power of 1 is the same thing as 9. Now 1 minus 9 is equal to negative 8, so I get 9 to the power of 900 times negative 8. Now from here, I said I was going to simplify this as much as possible, and we can't really get the exact value because 9 to the power of 900 is such a big number that we can't actually get the exact value for that. However, what we can get is the simplified value, and we're going to simplify it as much as possible. So I'm actually going to move this negative sign to the front, so I get negative 9 to the power of 900 times 8, and this gets me negative 3 squared to the power of 900 times 2 to the power of 3. We're simplifying these terms as much as possible. So I'm going to use a quick exponential property that states that a to the power of m to the power of n is equal to a to the power of m times n on 3 to the power of 2 to the power of 900. So I get negative 3 to the power of 1800 times 2 to the power of 3. So this is my final solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and even show this to any of your friends and family. That would support me a lot. I have a bunch of other videos similar to these on my channel, and if you're up for any challenges, I have a bunch of those, so please make sure to check them out. And thank you for watching. Bye.